Hello everyone, today we'll continue with conservation of momentum in two dimension. So before starting conservation of momentum in two dimension, let's solve one more equation. So first, one more problem. So first problem, 200 gram steel ball hangs on 1 meter long string. The ball is pulled sideways so that the string is at 45-degree angle, then release it. At the very bottom of its swing, the ball strikes 500 gram steel paperweight that is resting on a frictionless table. To what angle does the ball rebound? So first let's draw it. So this is our object, length L, mass M1, and it was released. This angle equal to 45 initially. Then at the bottom here we have a second object, mass M2. Yes, this is a horizontal surface. This will accelerate. Basically, here it will collide with the second object. And first we should find with what velocity it will come and strike the 500 gram steel. So let's find initial velocity just before striking the second object. Yes, let's call it V0. Now let's find this V0. This is basically final velocity or velocity just before striking the second object. So we can find it with the help of the energy, conservation of energy. So initially there is a height. Let's call it H. It means initially we have only potential energy, and it will be converted to the kinetic energy. So initial potential energy, and the final point is the point just before striking the object. So from here, as you see, V0 equal to square root 2 times gravity times height. So how we can find this height? Height actually, as you see from this picture, this is the length of the rope, which is L minus this part. This part we can find it from this right triangle. Yes, this is the right triangle. So this part equal to L times cosine 45. L times cosine 45. So this is the height, initial height with respect to the table, with respect to the surface. So from here we can find initial velocity just before striking the second object. So this is initial velocity. So let's find it in terms of magnitude, in terms of number. Square root 2 times gravity 10 approximately. Length is 1 times 1 minus cosine 45. So initial velocity approximately equal to 2.42 meter per second. This is the velocity just before striking the second object. So let's draw it again. Before collision, this was moving with velocity V2, mass M1. Second one was stationary. After collision, we will assume both will go to the right. V2, M2. We will assume, then we'll see what we can get. So conservation of momentum before collision, we have only M1 V0. After collision, M1 V1 plus M2 V2, because we are assuming that both will go to the right. This is a conservation of momentum. Let's call it first equation. So let me use in terms of gram. 242 equal to 200 gram times V1 unknown, M2 500 grams, V2 also unknown. Let me divide both sides by 100. So here we have a 4.84 equal to 2V1 plus 5V2. So as you see, we have one equation, two unknowns. So we need one more equation. This second equation we can obtain from the conservation of mechanical energy, because this is elastic collision. So initially we have only kinetic energy of the first object. Finally we have a kinetic energy of two objects. Yes, so this is how it looks like. Initial energy equal to final energy. Now we need to substitute numbers, datas, 200. We can multiply both sides by 2. So 2 we can cancel it. So 200 gram times 2.42 square equal to 200 times V1 square plus 500 times V2 square. So we can divide both sides by 100 again. Uh, 11.7 here. Here 2.V1 square plus 5 V2 square. So this is the second equation. So from these two equations we can find V1 and V2. V2, because we have two equations. If I'm not mistaken, V1 has two possible answers. First one approximately 2.4, second one minus 1. So of course this is in terms of math, these two equations has two roots, two possible answers, but in terms of physics we cannot accept the first one, yes, because in first case velocity of the first object equal to 2.4, almost the same initial velocity. It means, what does it mean? It means there wasn't any collision, yes, but we know that it collided with heavy object, 500 gram, so we should expect change in velocity. Second one, negative one. Negative means it will rebound, it will go back, which is logical, and velocity equal to 1. Velocity is equal to 1. So in terms of physics, second one is acceptable. So we will assume we choose the second possible answer, velocity equal to minus 1. Minus means just direction, it will go back, rebound. 1 is the magnitude of the velocity. Velocity. First answer we cannot accept. You see 2.4, it's almost its initial velocity before collision. It's like no collision, yes. So now we know the final velocity. It will go back and we should find height, yes. So we will face with a similar picture, similar figure, just instead of 45 unknown angle, and unknown angle we need to find this angle. So basically we will come back to this equation, yes. We need to write conservation of energy for the 200 gram only. We will not worry about the 500 gram. It will be moving to the right with certain velocity. It's not important for us. First one, instead of here we need to use 1 meter per second, and from here we can find alpha. So let me write it again quickly. So initially it will have this kinetic energy. Finally it will reach certain height h, and this height we can write in terms of angle, yes, cosine alpha. That's all. From here alpha, if alpha equal to approximately 18, I think 18 degree, it will raise for 18 degrees. Okay, now let's continue with collision or conservation of momentum in 2 dimension. So basically in 2 dimension, very simple. The logic is this one. Momentum will conserve in both directions. In x direction, in horizontal direction, also it should conserve in vertical direction, in y direction, let's say. So basically we can write this kind of equation. Total momentum initial in x direction should be equal to total momentum of the system after collision. Same for vertical direction. Initial momentum in y direction, in vertical direction should be equal to final momentum in the y direction, in vertical direction. Don't forget, you should remember, momentum is vector, so it has a direction. So direction is very important. So let's do this example. As you see in this figure, we have a collision between 3 balls. We have 3 balls, mass given, initial velocity given. The 3 hits simultaneously and stick together. They collide at the same time. and becomes one object. What are the speed and direction of the resulting bulb? So let's draw it. Let's draw direction of momentums initial of the system for these three objects. 40 gram is moving to the right, yes, in terms of x component, and this x component equal to m1 v1 cosine 45, and it has a y component downward, m1 v1 times sine 45. Let's come to the second object, 30 gram. It's moving to the left, so it has a momentum to the left, m2 v2. No y direction, no vertical direction. Second one, last one, 20 gram, is moving upward, vertical upward, m3 v3. This is its momentum. So now let's use the first one, conservation of momentum in x direction. Before collision, we have this momentum in x direction and this momentum. Second one is negative because it's moving to the left. So basically, initial momentum in x direction, m1 v1 cosine 45, because positive because it's moving to the right, minus because it's moving to the left, yes, second one. That's all, and there is no any other momentums in x direction. After collision, so this part is before collision. After collision, they will stick together. They will be like one object, and they will move, I don't know, in any direction. So here we should write momentum in x direction. Yes. So let me write total mass. This is total mass after collision, and let's assume it will be moving with velocity vx in y direction. Yes. This part is after collision. So now let's solve it quickly. m1 is 40, velocity 4, cosine 45, minus 30 times 3 equal to total mass 40 plus 30 plus 20 times Vx. So from here Vx equal to, let's do it quickly, 40 times 4 times cosine 45 minus 90 divided by total mass 90 gram. Everywhere 90, so I will not convert it into kilograms. So velocity in x direction equal to 0.26 approximately meter per second. So as you see, velocity is positive, so it means it will be moving to the right. In x component, velocity will be directed to the right because we have positive number. Now let's write the same equation for the y direction. Initially, in y direction, we have the two momentums. Let me choose different color. So initially, this is a vertical velocity, this vertical momentum, and this is vertical momentum. m3 v3 positive upward because m1 v1 sine will be negative because downward. So initial momentum in y direction, m3 v3 minus m1 v1 cosine 45. This is a before, initial. Before. After, they will be moving together, total mass, one object, yes, after collision, and they will have velocity vy in y direction. This is after. So m3 v3 20 times 2 minus 40 gram times 4 sine 45, total mass 90 gram times vy. So from here vy will be equal to 40 minus 40 times 4 times sine 45 and divide by 90. Negative number we have 81. So negative velocity means it will be moving downward. If you remember, x is positive to the right, y is positive upward. Yes, we use it this system, this logic. That's why negative velocity in y means it will be going downward. So let's draw. Velocity is vector. This is x component. This is y component, downward. So this is resultant velocity, yes, or total velocity. Let's say this is angle. This is the velocity. So velocity will be equal to, we can use Pythagorean theorem. So from here, velocity equal to approximately 0.85. What about this angle direction? You know, from the vector geometry, tangent alpha equal to Vy over Vx. So 0.81 divided by 0.26. So from here we can find alpha. So angle is 72 degrees. 72 degrees. So this is the direction. Basically, we found final velocity, velocity after collision, and its direction, and its direction. Now let's solve second similar question. As you see in this figure, initially 10 gram was moving to the right, exactly in the horizontal direction with velocity 2. After some time, this 10 gram explodes, and we have 3 different parts: 3 gram, 3 gram, and 4 gram, as shown in this figure. Velocity of these 2 parts given, 12 and 10, direction also given. We should find velocity of the third part and the direction. We will use conservation of momentum in 2 dimensions. Yes. So initially we have only horizontal momentum, m times v initial. Let's see. After collision, let me consider only horizontal directions. So this 3 gram has a x component to the right, directions after. Yes, this is before, after. m1 v1 cosine 40, we need x component, and m3, the third part, has a x component, also direction to the right. m3 v3 cosine theta, unknown, and m2 is moving to the left, horizontal. So m2 v2, no angle, it's exactly horizontal. Now we can write conservation of momentum in x direction. As you see from this picture, from these directions, it's very simple. mv0 initial, final m1 v1 cosine 40 plus m3 v3 cosine theta because of direction, minus because of direction again to the left. Yes. So total mass 10, initial velocity 2, m1 is 3, 12 cosine 40, m3 is 4 gram, velocity unknown, angle unknown, m2 is 3, velocity 10. So from here we can find what is a v3 times cosine theta. Cosine theta, after simple calculations, 20 minus plus 30 minus 3 times 12 times cosine 40 divided by 4. So v3 times cosine theta equal to 5.6. So now let's write conservation of momentum in y direction. In the y direction. Initially, it was moving only in horizontal direction, so momentum in y direction initial, no, 0. After explosion, sorry, not collision, explosion. So m1, 3 gram, has a momentum in y direction, yes, vertical upward, positive because upward. m1 v1 sine 45, and the m3 4-gram has momentum in vertical direction downward. It means negative, yes. m3 v3 sine theta. m2, this one moving only in horizontal direction, so vertical component will be equal to 0. So very simple. Now let's write conservation of momentum in y direction. Initial in y direction 0. After exploding, m1 v1 sine 45 positive because it's moving upward, minus because third part is moving downward, yes, sine theta. That's all. So 312 sine 40 minus 4 v3 sine theta. So from here v3 sine theta will be equal to, after simple calculation, sine 40, 5.78 approximately. So we have two equations and the two unknowns. We can solve it quickly. Let me write here first equation, v3 times cosine theta equal to 5.6. So we can simply divide these two equations. So tangent theta equal to 1.06, yes. It means theta equal to 46, approximately 46 degree, yes. So we can come back to one of these equations and find velocity. v3 equal to 5.6 divided by cosine 46, 5.6 divided by cosine 46, 8.06. So this is a velocity of the third part, and this is the direction is 46 degree downward. So this is how you need to solve the problems. How you need to solve this problem. So your homework, you have a homework. You have a homework. 1 second. Why I cannot open it? Okay, we should find page. Rotational energy, we don't need rotational energy, yes. So you have three problems. Question 72, question 72, page 291, Randall, 72, and 81, this one 81, and 83, 72, 81, and 83. Three homeworks for next week. Thank you. Goodbye.